In this video, I'll be going through the Set 3 Express end of year 2022 paper for Pure Science. I will cover question 1 to 5. So you have to complete your correction before I release it on OneNote. So for question 1, not much of an issue. Most of you know that the scalar quantity are those that only give you the magnitude but not the direction. For 1B, most of you in my class got it correct. For those who got it wrong, please refer to the textbook, and by then I think you will be able to arrange it in ascending order. If not, you can see me separately. For part C, it is a tough question, and only a handful of you did it correctly. So the question asks you to actually break down the unit Newton, and we gave you a formula, F net equals to MA to assist you. So if you read your chapter 1 in your textbook, they actually tell you that for any equation, let's say F net equals to MA, the left hand side unit must be equals to the right hand side unit. So if we do this, and if we analyze this equation, you can see that I actually put this square bracket here. So when you reach JC, you will notice that this square bracket basically means that the unit of whatever that is being bracketed. So if you see a square bracket F net, it means the unit of F net. So the unit of F net, I think most of you know, would be Newton. And if you do the same thing for the right hand side, then the SI unit for mass would be kg, and the SI unit for acceleration will be meter per second square. So if you look at the second line of this expression, it is actually telling you that the unit Newton can be rewritten as kg times meter per second square. So the answer here, I would expect you to write kg times meter per second square. Just simple as that. For question 2, we are checking whether you know how to read a vernier caliper with zero error. So the first diagram, I blow it up, and you can see that at the beginning, right, the 2 0, the 0 on the main scale, so the numbers on top, it is called the main scale. So you can see the 0 at the main scale and the 0 at the vernier scale is not matching. So if it is not matching, we say that there is zero error, and basically this gap over here is the zero error. So it is very tough for us to read this gap. So what happened is that the vernier scale, we actually amplified this gap, and you can see here, okay, the width of this gap, right, will be corresponding to this mismatch over here. So you can see here, only this line is particularly aligned. So we know that actually from here to here represent the zero error over here. And because of that, you will need to read it from the right hand side. So we say that this is your 0, 1, 2, 3. So basically the zero error, right, is given by 0.03 cm, which is here. So this is our zero error. And because you can see that the vernier scale is on the left hand side of the main scale, we call this zero error negative zero error. And when the question asks you to state, you should give the numeric value of this zero error if you are able to do so. And if you look at figure 2.2, you can see that this particular measurement actually consists of not just one wire, but actually 5 diameter of the same wire. So because of that, after you get the reading from the vernier caliper, in this case it is showing 0.4 cm. After you compensate the zero error, you still need to divide the reading by 5 if you want to find the diameter of one wire. So with that, you can see my working over here. If you are able to deduce the correct reading after compensating for the zero error, you will be given 1 mark. And if you are aware, meaning that from your working, we can tell that you are aware that the reading actually consists of 5 diameter, and you divide by 5, we will give you the second mark. Okay, and of course, this particular operation, you have to follow least SF, in this case 2SF. Okay, for part C, right, I have gotten many good answers. However, because many of you are giving me very good answer, the demand of our answer key has to increase so that we can differentiate who are the stronger candidate and who are the weaker one. So because of that, we would like your suggestion to consist of these two key concepts. So what are the two key concepts? Number one is that the improvement should consist of an even larger number of readings. So for example, if you are taking 5 wire, 5 diameter like that, maybe you should try it with 10 diameter or even 20 diameters. And number two, we would expect you to take multiple reading from different location of the wire. So for example, if let's say you have a wire like that, maybe you should get the measurement here, then after that get the measurement here, then after that get the measurement here, and then you take the average. Okay, because there's no point if you have a wire and then you keep getting the measurement here and then you do it again at the same place and then you do it again at the same place, it will not be as effective. So because many of you can actually answer this question, the demand of the answer key would also increase during our benchmarking. So this is question 2C. For question 3, most of you are able to give me the vector diagram, so I will not go through it here. If you still have issue with vector diagram, please come and see your teacher or see me or ask your friend. Now what happened is that I think because of the way the question is phrased, many of you have mistaken this resultant force as the net force acting on the ship. They are not the same. This particular resultant force here is referring to the sum of F1 and F2 only, meaning that after drawing the vector diagram, you are summing up the effect of F1 and the effect of F2, meaning now in your free body diagram, instead of having F1 and F2 as two separate forces, by drawing the vector diagram and by measuring the resultant force, you essentially lump up F1 and F2 as one force. In fact, if you are getting the hint from the question, resistive force, you would be hint or you should have the insight that, oh, actually on the ship there is a third force, which is now R, and you know that R is an opposing force as suggested by the name resistive. So when you use your Newton's second law, F net equals to ma, your F net over here can be expanded into two terms. The first term is the resistive force. The second term will be the resultant force of F1 and F2, which is whatever you get from the previous part. Some of you may be asking me, teacher, how do I know that this is a minus? So for those of you who are from my class, I keep telling you, when we solve a question, we need to dictate where is the positive side. So unlike mathematics, the right side is not always the positive side in physics. When we want to decide which is the positive side, we look at where the object is going initially. So in this case, the boat is actually moving towards the left initially. So because of that, it will be more convenient for us to actually set the left hand side as the positive side. So if we take the left hand side as the positive side, then this vector R, the resistive force, would have to take up minus, right? Because it is going towards the right. We took the left hand side as positive. So any force that points to the right will be negative. So after you substitute what you have from part A, in my case, I got 90,000 from part A. Yours may be slightly different. Then you get your mass multiplied by your acceleration. And if you do your algebra correctly, you'll be getting the correct answer. For question 4, I just want to highlight when defining gravitational field, because this question was not answered correctly by most, we kind of make our answer key more relaxed. But I just want to highlight to you, when we talk about a field, this field is actually three-dimensional, meaning that it will have height, it will have width and length. So 3D. Okay. So if your answer says that gravitational field is an area, it is actually wrong, because an area is two-dimensional plane. A region is correct because a region describes three-dimensional space. And number two, in a gravitational field, it is not that a gravitational force acts on an object. Object is a very layman term. We know that in a gravitational field, only the mass is being affected. So because of that, we would expect you to actually write down the mass, the gravitational force acting on a mass. But like I said, for this case, we make the answer key less demanding. So we will accept object and mass. But for set 4, we will not. Okay, for part C, this question is also really being scaled down on its difficulty level. As you can see here, we are just asking for the magnitude and direction of a reaction force. We are not even asking you to name it. So if you have studied your Newton third law, you would know that this particular reaction force would give you the same magnitude as the original force, and it will act in the opposite direction as the original force. So this gravitational force acting on the spaceship, right, this one is actually a downward force. So for example, if you have your spaceship over here and this is mass, then the gravitational force acting on the spaceship will be downward. So as a result, your reaction force will be upwards. Okay, and your reaction force should be acting on mass. So for those in my class, I keep telling you this relationship for reaction force, FAB versus FBA. What does this mean? So this gravitational force, the original force, the gravitational force is a force acting on the spaceship by mass. So its reaction force, its reaction pair would be a force acting on mass by the spaceship. So therefore, this particular reaction force is actually acting on the mass upward. Okay, so action-reaction pair, they actually act on different object. Okay, last question in the video, question 5. Most of you are able to give me, at least in my class, the principle of moment, and we are actually very lenient in our marking. In O level, it is either 2 marks or 0. Now we give you working marks. For those of you who couldn't answer part B, it is actually a very simple moment question. This moment question, right, in fact, is for N level. Right, in N level, when we have an object, we will have two forces. One force gives you an anti-clockwise turning effect, whereas another force gives you a clockwise turning effect. When you reach secondary 4, moment question will consist of 3 or 4 forces, and you may have 1 or 2 pivot to choose from. Okay, in fact, some of them may even ask you where is the weight, and you are supposed to locate the center of gravity. So actually in this particular test, we are really giving you some, leniency. So for question 5, if you are unable to calculate part B, please see your teacher immediately. Okay, in this video, I just want to highlight, if you are unable to solve this, most likely is because you use the wrong length. So for example, if let's say you want to find the turning effect caused by the force F, you have to first draw the line of action for force F, which is this highlighted line. And you can find the perpendicular distance from the pivot to the line of action, which is given by this. So it is actually 40 cm. Okay, you should be able to identify by now that force F would give an anti-clockwise turning effect, whereas the weight is giving you a clockwise turning effect. So in order for this particular stool to actually remain balanced, the clockwise turning effect and the anti-clockwise turning effect must balance each other. So therefore, you would have a working like this. So this clockwise turning effect is caused by the 30 Newton force, as you can see here. And the perpendicular distance for this turning effect will be 6. and then after that the anti-clockwise turning effect is actually caused by the force F over here, and the distance is 40. So if you equate them, you should be able to get this. Okay, for part C, it is a slightly harder question. So the question says that the center of gravity of the stool has actually been shifted to D. So if you shift the center of gravity to D, you can see that the weight over here is actually on the left side of this particular pivot. So I'm going to draw this diagram over here for ease of reference. So now because the CG is now on the left side of the pivot P, you can see that the weight, which is a force, is going to give rise to an anti-clockwise turning effect. We call this anti-clockwise turning effect moment. So the key concept here that we want to see is that in your answer, you are telling us that this force is going to produce a turning effect. So the answer here, I would expect you to tell me that because of the change, the weight, which is a force, is going to produce an anti-clockwise moment about P. And because now the weight is producing an anti-clockwise moment, if we want to keep the stool balanced, we must then change F to act towards the right. So for example, if now my F right is acting towards the right, F will now produce a clockwise moment, and this particular clockwise moment would allow us to balance the anti-clockwise moment produced by the weight. Okay, so this is the end of the go through for question 1 to 5. Please like and subscribe so that I can upload more of these videos. Okay, goodbye.